My name is Sabit Chibet, and I'm going to take you through our product page. This is for an idea we worked on as a group. The name of the product is EduVision. This target customers, the parents of children with learning disabilities, the caretakers of these children, and the teachers that interface with them. So our project is in line with SDG4, which is to do with providing inclusive and quality education to learners or learners. Now, the core problem is now with the rise of home-based learning, a number of caretakers, teachers, guardians, or parents of children are not well equipped with tools to provide them with curriculum-aligned content to support their learning. So we decided to come up with a tool that would be able to provide this kind of support for these children, but majorly for the mathematics subject, which is actually one of the key foundational subjects for children to learn. So this majorly affects the teachers, the guardians, and the learners. And so this tool is supposed to be like a point of access for all this information that they can get. It's supposed to be more accessible. It's supposed to also provide context-aware content for these learners to help just support their education and make it easier for them to pick up these concepts. So the impact we expect for it to have is we expect that it's going to improve learning outcomes and also reduce the teacher workload because it's a co-teacher. And we also hope for it to help students develop a stronger foundation in mathematics. So the primary users of the system are going to be the parents and guardians, or caretakers of these children, learners as well. The secondary stakeholders are going to be the Ministry of Education and Sports and the curriculum developers, that's NCDC. Then in this ecosystem, we have a number of points, and one of them, the data suppliers who supply us with content we need. The content we need to process, the model we need to process, that's the data set. That's NCDC, that's our major data supplier. And then we have algorithm developers who develop the code, platform maintainers, validators who are supposed to make sure that the outputs of the model are in line with the informed pedagogical strategies for teaching children. So the government entities that we expect to oversee this are data protection authorities and the Ministry of ICT and National Guidance. So the data was made text-based, and the sources included the NCDC. This provided teaching manuals, textbooks, and we also got reports on learning disabilities, because that's our main focus, learning disabilities, and pedagogical strategies. So the pipeline consisted of us collecting data from these sources, extracting them using an AI tool, cleaning this data that involves deduplicating and standardizing labels, validating it to make sure it's up to the standard we want it to be in, and then securely storing it. So we made sure throughout this process that our data was collected ethically and responsibly, and was following or in line with the policy frameworks that exist concerning data collection in Uganda. Now, the use of this data it's supposed to inform the kind of output our model produces. So quality data equals quality output. So the kind of model we employed for this system is a decoder-only transformer-based called the Falcon 3.1B extract. We fine-tuned it using LoRa, which also helped reduce the computational resources it used. And so how the system is used is we basically have a user. We're entering a prompt. This is the input. This prompt is processed by the model to produce an output, which is a response, which is in line with that the user entered as a prompt. So this can be things like teaching plans, assessments, or learning space setups, depending on what they prompted the system for. So now this transformer-based model works with grouped query attention. Grouped query attention helps extract contextual meaning from these tokens. The tokens come from the input. Helps extract contextual meaning from the input. And now this contextual meaning in form of weights is passed on to the feed-forward layers. The feed-forward layers define this to produce more structured vision. So after all this, we were able to use Gradio UI in order to develop an interface, the model. This is what the users will be using whenever they log into the site or whenever they visit the site. And we also plan on having an API that can allow the system be integrated with other systems. This is for maybe schools that may want to integrate it into their other systems. Throughout all this, we made sure to use tools that would help make our system more transparent, in order to make it easier for the relevant stakeholders to see how the model reasons and what informs its processing of these outputs. So now, the metrics we defined for the success of this model were in 3 categories. The technical metrics, we had a response accuracy greater than or equal to 70%. This is basically how much the model's output is in line with what we expected. Latency of less than 10%. This is how fast the model takes to return output from input. The user-centric metrics included an adoption rate of 55%. So this is for all people who write to use the system. We define our success rate to be 55%. So that's 55% of them staying and actively using the system. And a user satisfaction rate of less than 80%. Ethically, we decided to go with a model transparency rating of 85%. Now, this is important because this rating helps, it helps with transparency. And this transparency is going to inform how much our stakeholders put trust in the system. And this is mainly done using model cards. For the bias detection and mitigation score, we decided to go with a score that is greater than 70%. This is basically for all the biases we have identified in the system, how many have we been able to resolve? Commercially, we defined our success rate to be a revenue growth manner, which is greater than 20%. So now what advantage do we have over other products out there? First of all, we have we're able to create a data set from NCDC aligned content. Besides that, we're also able to employ inclusivity in this. Add information to do with these learning disabilities, because this is actually more targeted at students with learning disabilities. Besides this, we're also able to contextually ground it. This is through the integration of locally relevant materials that would be used for producing assessments, be used for producing lesson plans. And we also have human in the loop evaluation. This is where our stakeholders validate the output and then give us feedback that we can use to improve the system. We also plan, we haven't done this yet, but we also plan on having a compact distilled version that will be able to run offline on mobile devices. So how do we plan on distributing this, and how do we plan on marketing this? We plan on using social media platforms such as WhatsApp, Instagram, and LinkedIn, and also through participation in innovation weeks and exhibitions in order to put our project out there and inform more people about it. So what we're actually expecting, what we plan on delivering to them, is a compact, distilled, mobile-friendly version. Again, like I said before, that can be used in resource-constrained environments. Another partnerships we intend to partner with the NCDC and Ministry of Education, because again, we're providing education material and it needs to be aligned with the country's curriculum. We also plan on partnering with NGOs, and throughout the entire process, we also hope to use the continuous updates we receive from stakeholders to refine the model so that we can produce output that they are more satisfied with and keep them more engaged in the application. So how do we plan on making money from this? So what we decided to do, we decided to have a free version and a premium version. Now, the free version of this application is supposed to have core content and more generalized. It's going to have more core and generalized content. This is just generalized teaching plans, generalized assessments. But then the premium version is going to have more personalized content that's more personalized to the learners. So we plan on keeping this more affordable for the people paying, the households paying, that is, through accessing grants. The grants we access will help us. This is actually an indirect input, indirect source of revenue. We plan on partnering with NGOs and receiving grants from them so that we can be able to keep the price as low as possible for the people who are going to be paying the system. So the direct source of revenues are the customers paying for this. Some of these customers are going to include, we hope will include schools and teaching institutions. And we also hope to have value-added streams such as sponsored research projects and grants that would be interested in the work that we are doing. So the key resources employed in this project are basically in 5 categories. The first are human resources, people who are at the front line of working on this, the maintainers, people writing the code. These are we hope to have AI engineers working on this, data scientists, experts in the field to help validate the input. For the technical infrastructure, we plan on, these are GPUs and TPUs that are basically important for training and testing, and also fine-tuning the models and deploying them for inference. And then the data structure is basically consisting of the data set that we're able to retrieve from all these sources spoke about earlier. The organization resources are through partnerships with the Macquarie University School of Education and the NCDC, that's the Ministry of Education and Sports. The financial resources we hope to obtain for now are from grants from different partnerships with non-governmental organizations. We hope that this will help us at least develop the system to a certain point and also help us keep the rates as low as possible in the future when we start having users paying for the system. So the key activities to this include the model. We have, again, the switching categories. The model's lifecycle activities basically include activities such as data collection, which we did, training of the model using this data, testing it, retraining it in case there are like large changes to the NCD's curriculum, and deploying the model after this entire process. So for now, we have not yet used MLOps for this, but it's a future plan that it's something that we hope to do in the future. That is automating these processes. For instance, when new data is added, we should be able to have the model retrained automatically, and then after validation, we should be able to have it deployed automatically as well. That's something we need to that's a future plan we have. We also have product development activities that are majorly to do with developing the UI system for our users, adding more interactive elements to the UI. Operational activities, this involves continuous monitoring. This is of the latency. This is basically to do with it's going to help us know how well the model is performing and how we need to improve it as well. The governance and compliance, this is basically to do making sure that our model is explainable and transparent and in line with the current laws that there are. Customer focused activities include training, holding workshops in order to make sure that we help people learn how to system more effectively, and also taking in their feedback to iteratively to improve the system. The key partners we have the technological partners. These are also partners that help us in terms of innovation. We have the Hugging Face spaces, which is where the system is currently employed. We plan on upgrading to a more scalable system in the future. And we also have Bradia UI that we used for the interface design. The data partners we had were the National Curriculum Development Center. This is where actually and this is where our data in terms of the teaching manuals came from, because everything's supposed to be aligned with the national curriculum. And then NGOs such as UNESCO, these are some of the platforms basically where we're able to get more information on some of these learning disabilities. The ethical oversight partners are supposed to make sure that we keep in line with the ethical standards that have been set for data protection, and include the Ministry of ICT, the National Guidance, and the PDPO, the Privacy Data Protection Office. The distribution partners we intend to have are the Uganda Communications Commission, through their Communications Universal Service and Access Fund. This is basically going to help us push this project idea into rural areas that will be a bit harder for us to reach, and also help us promote inclusivity, which is actually one of the core things we plan on doing for this project. The strategic collaborators we have are the Uganda Society for Disabled Children and the Department of Special Needs Education, Macquarie University. Again, these are going to help us keep refining the content of the idea we have for this project. Now, the cost structure consists of data costs, compute costs, human resource costs. I'm going to take us through some of them. The data costs are mainly from accessing content we need to enrich the project. And this may be in form of textbooks, a number of which we will have to buy, a number of which we will need licensing and permission for before we can access. It's not only textbooks, it's also information that requires us to obtain permission before we can fully access it. Some of these things may be teaching manuals that may not be publicly accessible, that need permission. Computer and infrastructure costs mainly come from the use of GPUs and TPUs for training and deployment, because we're going to have to eventually expand to a paid version. For example, using Collab Pro for our training and testing. Human resource costs are to do with what we are paying, for the people we are paying, costs related to the money we are paying for the labor. That's to people such as lead engineers, data scientists, marketing personnel. The compliance and legal costs are going to mainly come from the IP registration, the PDPO registration. That's about 100,000 per annum, and that's 100,000 for registration, and then 100,000 for subscription each year. The marketing and distribution costs are going to come from promotional materials, entrance fee for participation in innovation weeks and exhibitions, and we estimate for now, though this is going to change, going to be 600K annually. Maintenance and scaling costs are going to come from us transitioning from the current deployment site we have to a more scalable one in the future when we have more users coming in. This is to have access to the GPUs that they use We approximate that it's going to cost about 3.4 million. This again is going to change, subject to change. Now, in order to perform transparency, we hope to publish model cards and data statements to summarize the data set, that summarizes data set composition and collection processes. This is to make the system more trustable. And we're also going to do fairness and bias auditing. This is by utilizing open frameworks such as FairLearn and AI 360 to check to know whether our system is being biased towards a particular group of people. Explainability tools such as CAPTAM and attention weights. Weight heat maps are going to help us make sure that stakeholders how our system reasons in order to produce the output, again promoting transparency. Legal and ethical frameworks we plan on adhering to are the UNESCO recommendations for ethical use of on ethics of artificial intelligence and the Privacy Data Protection Act of Uganda. Accountability, we plan on being accountable to our stakeholders. And this is also through iteratively taking their feedback and then incorporating that into the changes we expect to have made to improve our system. So the scalability, for scalability and sustainability, we are currently planning on transferring to a paid tier for deployment. Again, this is going to be very important when we are scaling up, when we are adding more customers, more users to the system. We also want to distill the current model into a smaller version that will be more accessible for mobile offline devices and transition to more scalable platforms such as AWS and Azure. For continuous learning, we plan to update the model based on continuous feedback from the relevant stakeholders and any changes made to the NCT's curriculum. As for localization, we plan on improving the system because we've already added some bit of context-aware data to it, but we want to continue tailoring it more so that the examples will fit more in the cultural context. That's whether it's urban or rural environments. For financial sustainability, we for now we are hoping to rely on partnerships with NGOs so that we can provide more affordable fees to the current customers. And we plan to invest this in sustaining the local infrastructure we have and maintaining the model. For environmental responsibility, we plan on limiting the number of times we retrain and also on using that distilled version so that we can also reduce the time we use GPUs and also that we help reduce the carbon footprint. For resilience, we plan on backing up the system just to protect the data we have from power supply interruptions and hardware difficulties. So currently the intellectual property we have includes the fine-tuned model that we have produced, the fine-tuned language model, and the knowledge graphs that help link these different concepts and also help inform the model's reasoning. So the team contributions, all team members were involved throughout this process, from the data collection to EDA and training and testing, except for deployment, where we had one member deploy the model to spaces. So thank you so much for listening.